I welcome all of you to my channel Learning with Faraz. As we're continuing the Python series, this is going to be the next part in that. So we have started object-oriented programming in Python. So in this video, you're going to study inheritance in Python. So by the end of this video, you will be very comfortable with this inheritance in Python. If you understand the fundamentals, you can use these fundamentals in any programming language. So stay tuned with me. If you haven't subscribed to my channel yet, please subscribe to it, press the bell notification and like this video and share with your friends. Let's get started. One of the most important feature of object-oriented programming is inheritance. Now what is this inheritance? So as its name indicates, the word inheritance itself means, like, if you have parents, you have their property, you have something with them that will be yours in the future, so you will inherit their property in the future. So that's what inheritance by word means. So what is the meaning of inheritance in programming languages? For example, if I have a class which is having a functionality which I want to use in my own class. I have one class which is there. In that class, I have my requirement in that class. But in my class, I want to use that requirement without writing the code again. So that's what, like, if I want to use that functionality in my class, I have to apply this inheritance concept. So inheritance concept is basically taking the attributes and which are non-private, which are not hidden methods from other class to our own class. You can access those methods and those variables once you apply inheritance there. So in the inheritance concept, there will be I'll explain you what are the types of inheritances in Python. But before that, let me just explain you the fundamental thing here. In inheritance, there are two words here. One is a parent class, the other is a child class. Parent class is also called as base class. Child class is also called as derived class. So try remembering these words for now. Parent is also called as base class. Child is also called as derived class. Now, one of the main advantage of inheritance is something that is called as code reusability. As it is self-explanatory by word itself, the code reusability means you have a code that is already written, you're going to use it again. Code reusability is the main advantage of inheritance. So what I'll give you two scenarios, one with inheritance, one without inheritance, so that you can see the difference clearly. First example, I have a class X which is having m1 method. I have a class Y which is having m2 method. I have these two classes and these classes have no relation at all. So if I create an object for X class, I can access m1 method. If I create object for Y class, I can access m2 methods. That's very simple. But if I make some relation between them, see what happens with the object that I have. If I make X as the parent and Y as the child, how do I make it as a child? I will put in the parentheses that class name. So I'll put here, so I'll put in the bracket X. So this class will become the child of the above class that I have. So once I create a relation, once I create a parent and child relation, if I create an object for class X, I can access m1. But if I create object for Y, I can access m2 and m1 as well. So this explains that the child is having the accessibility for the parent methods that we have, or the data variables for the parent that we have. So that's by creating this relation, I can use that m1 method in my class Y or with the object Y. So that there is a difference in the behavior of the object, and the things that are there in the parent class are by default available to the child. Even if you keep the child class empty, that things in the parent class will be available to the child itself. I'll show you in the implementation part that as well. So let me take you forward. Let me move you to the certain simple concepts here. In Python, like basically I can say there are three kinds of inheritance that you can use. first is a single inheritance, like one parent and one child. That's a single relationship. There is one more relation that is called as multiple relation. Like I have a class which is having more than one parent. It's like I have one child and two parents. Like it's a multiple inheritance. And the third inheritance is called as multi-level inheritance. I have a parent, that parent is having two childs, this child is having one child again. Like you can see the levels here. So I will explain these inheritances with example in the implementation part. So the main advantage of inheritance is code reusability. In simple scenario, if I have a class maths, in that class I have mathematics basic functionalities like power, square root, addition, subtraction, and so many things I have in that. And I am creating one class for myself, a triangle class. So while writing the triangle class, I got a requirement of calculating the area of the triangle. So if you know, area of a triangle can be calculated with three formulas. One of them is the Heron's formula, the other two is half into base into height, the other one is half x1 y2 minus y1. That's a coordinate geometry formula. So I'm not going to go into that for now. I'm going to consider Heron's formula. So if I'm using Heron's formula, it says under root of s minus a, s minus b, s minus c. So if I want this square root functionality to be used, I can make my triangle class the child of the math class. So this was the basic examples for inheritance in Python. So that's it for inheritance. I hope you enjoyed this video, understood this video. Let us go to the implementation part and understand it more practically. So stay tuned with me. Thank you very much. Okay, so this is going to be an implementation part. So I have already done a simple script to make you understand inheritance. So let me open that first. So let's try and understand this. It's very simple. I have created a class here that is called as maths, and that I have defined a method square root that's gonna return the square of a number. You know what this is? It means power, n power 0.5, that means n power half. That's gonna be a root. So I have created another class called as child. Within that I'm passing, like I'm telling that this math is going to be the parent of the child. So that means this class can access this method. So I have created another method def cal square root. I'm passing the first mandatory argument and my number, and in this I'm just printing, or I can just return self dot square. So this one is right here. So you can observe this. I can access this method from this class because this is the child of this. So that's what the advantage is. So let's move forward. So I'm gonna create an object for this class, and I'm gonna check if it's working. If I can, from this object I can access this, that's a normal thing, but from this object can I access this? So we are going to test that. So I've created an object for the child class, and I'm calling call square root, this one. Within that I'm passing 16, and I'm just calling this method to return 4 to me. So it's gonna return 4 to me. Let me just print this statement so that you can see. Let me just put it like call from child object. So let me just put there, and for this I have this object, so I'm checking if from this object can I access this class's method. So I will call it as call from child object. It's called from child object to child method to parent method. So let's just compile and run our code, sorry, interpret. So you can see call from child object to child method is none. So let me just test it. So I have called this 16, it's passing 16 and calling 16. It's not returning, sorry, that's what it's returning, none, right? You understood that error? Now it's not gonna give me that. I got it, right? So if I call from child object a child method, it works. If I call from child object a parent method, it still works. That means that a child method will always have its parent methods by default. I think that's clear for it. That was a very basic example of inheritance that I can show to you. I can also show you so many complex examples that I'm going to show you in the upcoming part, so do not worry about it. So let me just show you one more example here. You can also make this as a child of some other method, some other class, sorry. You can make this as a child of some other class and you can still access these methods. So try and understand this reusability is very much important when it comes to inheritance. So there are certain examples that I want to show you, so that's gonna help us to understand inheritance in a better manner. So this example is going to be a bit complex one, so you have to bear with me. So let me just create a new file. So I'll show you my strategy first before writing any code. I'll just show you my plan. So I'm gonna create two classes. Then I'm gonna call this class as polygon, and I'm gonna name my second class as triangle, because triangle is a type of polygon. You can use any other thing instead of that, not compulsory. So what does my polygon class gonna have? Is gonna have a constructor, is gonna have a method which is, I'm calling it as input sites, because it's gonna return me the number of sites that user is gonna return to us. To take input inside, I can say that number of sites and the input of number of sites. And next thing is display sites, like how many sites the user have entered. That's it. Now coming to this one, to my triangle class, I'm going to create another constructor, and I'm gonna also create find area of triangle. That's it. So this is going to be my strategy for this video, to show you the inheritance part using this video. So I think you understood this. I'll show you the reason behind every method here. Constructor to initialize our variables that we want to use at runtime, because when I create an object, it should have some value in it, or otherwise my object will point to null. So input side is going to help us with taking the input for the sites. Like if I have 3 sites, it will let me know that, yeah, please input 3 sites. If I want 4, I can go 4, and so on and so forth. Display side is going to display how many sides I have. The constructor for triangle is going to initialize my values by using this constructor. So what I'm going to do here is, it's very interesting, from this constructor I'm going to connect this constructor. So you're going to see that relation from constructor to initialize the values, and this is going to take these values, sorry, this is going to take the values and show us the result. So this is the entire story that I'm going to implement in the coding part. So let me just begin.